Hello everyone, this is Keith Jackson and welcome to Jack's Math Notebook. In this video, we're going to learn how to subtract mixed fractions with unlike denominators using the least common denominator method. And we have these three big examples to show you how we can do that. And let's begin with 6 and 3/4 minus 4 and 2/3. Okay, and as you can see, 4 and 3 are different denominators. So we're going to have to find a way to find the least common denominator between 4 and 3. And we're going to count by fours right here. 4, 8, 12, 16, 20, and let's count by threes, in which we have 3, 6, 9, 12, 15. And guess what? Our magic number, our least common denominator in this case, will be 12. And so let's park a 12 right here in the denominator slots for our new fraction or our new equivalent fraction. And so when we do that, we know that 3 times 4 will give us 12, and whatever we do to the bottom, we do to the top, and 2 times 4 will give us 8 because we know that 2/3 is the same as or equivalent to 8/12. And let us do the same thing with 4 in the denominator. Multiplying it by 3 will give us 12, and whatever we do to the denominator, we do to the numerator. And so we know that 3 times 3 will give us 9, and let us know that 3/4 is equivalent to 9/12. And let us do our subtraction. And so we know that 9 minus 8 will give us 1. We just keep the denominator as is, which is 12. And we know that 6 minus 4 will give us 2. So our answer is going to be 2 and 1/12, y'all. Now let's move on to the second big example in which we have 9 and 5/7 minus 3 and 2/3. Noticing that our denominators are different. The denominator here is 7 and the denominator here is 3. And let's find a least common denominator between those two numbers by counting by 7s and then counting by 3s. And so if we count by 7s, we have 7, 14, 21, and 28. And if we count by 3s, 3, 6, 9, 12, 15, 18, 21, 24. There it is. 21 is our magic denominator, y'all. And let's plug that 21 into our denominator slots for our new fraction. And so we know that 3 times 7 will give us 21. And whatever we do to the bottom, we do to the top because 2 times 7 will give us 14, letting us know that 2/3 is equivalent to 14 over 21. And let us do the same thing with 7 in the denominator by multiplying it by 3, knowing that it gives us 21. Whatever we do to the denominator, we do to the numerator. And 5 times 3 will give us 15, letting us know that 5/7 is the same as 15 over 21. And let us do our subtraction. 15 minus 14 because we're subtracting the numerators, right? And so 15 minus 14 will give us 1, keeping the denominator of 21. And that part right here will be 1 over 21. And we know that 9 minus 3 will give us 6. And so our answer is 6 and 1 over 21. And let us move to our third big example in which we have 8 and 5/8 minus 5 and 1/4. Noticing that 8 and 4 are different denominators, so we're going to have to find the least common denominator between these two denominators. And we can do that by counting by 8s and then counting by 4s. And when we count by 8s, we have 8, 16, 24. And when we count by 4s, we have 4, 8, 12. And guess what? 8 is our magic denominator in which we're going to plug into our denominator slots right here to make our new equivalent fractions, right? Because we know that 4 times 2 will give us, say, whatever we do to the bottom, we do to the top. 1 times 2 is 2, okay? And since we have 5/8 right here, because we just keep it, right? Because we have 5/8, we have 5/8 here, because here's why, because we know that 8 times 1 will give us 8, while 5 times 1 will give us 5. So we could just keep that as is. And so let us do our subtraction of these two fractions. 5 minus 2 will give us 3, keeping the denominator of 8. And we know that 8 minus 5 will give us 3. And our answer in this case is 3 and 3/8. Y'all, all right, we're finished. Okay, you have been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at these three big examples or replay this video as many times you need to gain a deeper understanding of subtracting mixed fractions with unlike denominators using the least common denominator method. All right, but in the meantime, please comment, share, like, subscribe, and I repeat, subscribe, okay, and like to Jack's Math Notebook for more content. Thank you and goodbye.